All right, in problem number 7, we have 3x minus 8y minus 2z is equal to negative 8. And then 2x plus 6y minus 5z is equal to 14. And x minus y is equal to 2. So we're going to use matrices to solve this system of equations in 3 variables. In this case here, we have to first write this as an augmented matrix before we do anything. All right, so the first equation, 3x minus 8y minus 2z is equal to negative 8. I need to write that as, in this case, 3, then negative 8, negative 2, negative 8. And then the second equation, 2x plus 6y minus 5z is equal to 14. That equation would be written as 2. For y, it would be 6. For the z, negative 5. The constant term would be 14. And then finally, for x minus 2y is equal to 2. Well, for the x coefficient is 1. The y coefficient is negative 2. What would the coefficient for z be? 0, because there's no z term. If any term, x, y, or z is missing, we put a 0 there. The constant term is 2. Okay, so that's our augmented matrix. Now let's start this by getting a 1 in the upper left-hand corner of this matrix. Well, notice we got a 1 down here in that third row. So I'm going to interchange row 3 and row 1. So that matrix operation would be this. I'm going to say this, row 1. I'm going to interchange that with row 3. Row 1 will be interchanged with row 3. And when I do that, that first row would go into the third row, which will be 3, negative 8, negative 2, negative 8. Row 3 becomes row 1, which is 1, negative 2, 0, 2. Row 2 stays the same. Okay. Now, I have a 1 in the upper left-hand corner. I need zeros underneath the 1s here. So I need that 2 to be a 0, and I also need that 3 to be a 0. So here you can do matrix row operations in pretty much one step, just to save time. For this to be a 0 here, I need to do this. I need to make negative 2, take negative 2 multiplied by row 1. Add that to the corresponding elements in row 2. And I'm also going to make the 3 0 by doing this. Negative 3 times every element in row 1 plus the corresponding element in row 3. So here you can do 2 matrix row operations simultaneously. So when I do that, row 1 remains the same. Now here's what row 2 is going to look like, and I'm going to get another sheet of paper and scratch work so that way you'll see what I'm doing here. Let me move this up. Negative 2 times row 1 plus row 2. That's going to be this. Negative 2 times this element in row 1, which is 1, plus the corresponding element in row 2. That's going to be negative 2 times 1 plus 2. Well, negative 2 times 1, that's negative 2, plus 2 is 0. So I'm going to have a 0 here. And then negative 2 times this element in row 2, that's negative 2, plus its corresponding element, which is 6. Well, negative 2 times negative 2 will be 4. 4 plus 6 ends up being 10. So 10 goes here. And then negative 2 times this element in row 1, which is 0, plus the corresponding element in row 2, which is negative 5. Negative 2 times 0 is 0, plus 5 will be negative 5. And negative 5 will go here in this column. And then I'll have negative 2 times this element in row 1, which is 2, plus the corresponding element in row 2, which is 14. Negative 2 times 2 will be negative 4. Negative 4 plus 14 is 10. Okay. Now row 3 is going to change as well, because this time I'm going to be taking negative 3 times every element in row 1, add them to the corresponding elements in row 3. So in this case, negative 3 times this element in row 1, which is 1, plus its corresponding element, 3. So negative 3 times 1 would be negative 3 plus 3 is 0. That 0 goes here. And then next, let's see, negative 3 times this element right here, which is negative 2, plus negative 8, the corresponding element in row 3. So negative 3 times negative 2 will be 6. 6 plus that negative 8 will be negative 2. And then we'll move over to 0. That would be multiplied by negative 3 times the element in row 1 plus the element in row 2, that's negative 2. Negative 3 times 0 is 0, plus negative 2 will be negative 2. And then we'll do negative 3 times the element in row 1, which is 2, plus the corresponding element, which is negative 8, which is in row 3. Negative 3 times 2 is negative 6. Negative 6 plus negative 8 would be negative 14. So negative 14 goes here. Okay? All right, next. Here's what I'm going to do here. Let's look at row 2 and row 3. In row 2, those elements are multiples of 5. So what I'm going to do there is take 1/5 of each element in row 2. And also look at row 2. Negative 2, negative 2, negative 14. Those are multiples of 2 as well, but they're all negative signs. So what I'm going to do here is multiply row 3 by negative 1/2. So in this case, row 1 stays the same. So it'll be 1, negative 2, 0, 2. Row 2, if I take 1/5 of 0, that's 0. 1/5 of 10, or 10 divided by 5, that'll be 2. 1/5 of negative 5, or negative 5 divided by 5, that'll be negative 1. And 1/5 of 10, again, that'll be 2. Now for the third row, I'm going to multiply each element by negative 1/2. So negative 1/2 times 0 is 0. Negative 1/2 times 2, that's just going to be a positive 1. And then negative 1/2 times negative 2, again, that will be 1. And then negative 1/2 times negative 14, that would be 7. All right, now I have a 1 with zeros underneath it. I need a 1 right here. But notice I got the 1 in the third row. It would be best to interchange row 2 and row 3. So row 2 will be interchanged with row 3. Again, row 1 remains the same. Row 2 becomes row 3, so 0, 2, negative 1, 2 will go into row 3, whereas 0, 1, 1, 7 goes into row 2. All right, now I need a 0 underneath this 1 right here. Well, I got the 2, so if I want that 2 to be a 0, this is what I'm going to do. I will take negative 2 times every element in row 2, add the corresponding elements to row 3. So let's see, row 1 is the same. Row 2 is going to be the same as well, only row 3 is changing. So here's what I'm going to have for that. This up a bit. So this is row 2 right here. So I'm multiplying negative 2 times each element in row 2, so it'll be negative 2 times 0, plus its corresponding element, which is 0. Well, negative 2 times 0 is 0, plus 0 is 0. So that 0 goes here. And then negative 2 times this element, which is 1, plus its corresponding element, which is 2. Negative 2 times 1, that's negative 2 plus 2, which is 0. So that's going to go here. And then well, I'm almost done. Negative 2 times this element in row 2, which is 1, plus its corresponding element, negative 1. Negative 2 times 1, that's negative 2. Negative 2 plus negative 1 will be negative 3. And negative 2 times this constant, which is 7, plus its corresponding element, which is 2. Well, negative 2 times 7 is negative 14. Negative 14 plus 2 is negative 12. So negative 12 goes here. And I'm almost done because notice I have a negative 3 and a negative 12. They're multiples of 3. So I can get a 1 right there easily. And since they're both negative, I'm going to do negative 1/3 times every element in row 3. Negative 1/3 times every element in row 3. So bring over row 1, bring over row 2. Now, if I do negative 1/3 times 0, that's 0. Negative 1/3 times 0, again, that's 0. Negative 1/3 times negative 3, that will be a 1. And negative 1/3 of negative 12 will be 4. So notice I have a 1 along the main diagonal and zeros underneath those 1s. So this matrix is in not reduced, it's in row echelon form. Okay, so now let me rewrite my equations. That first row is going to be x minus 2y plus 0z, which is, we don't need to write that, so it'll be x minus 2y is equal to 2. Here's the second equation, y plus z equals 7. Then the last equation, z is equal to 4. Because that last row tells you what z is. And here z is equal to 4. So now we can do the back substitution to find out question. Okay. So here we can do the back substitution to find out what y is and what z is. So here we're going to have y plus z, which is 4, is equal to 7. And then subtract 4, you'll get y is equal to 3. And then use that first equation. Only thing we need to substitute there is the y with 3. So it'll be x minus 2 times y, which is 3. is equal to 2. 2 times 3 will be 6, so x minus 6 will be equal to 2. Add 6 to both sides, you'll get x is equal to 8. So now the solution for that system of equations would be the order triple, 8, 3, and 4. Okay. All right, are there any questions about solving a system of equations using matrix row operations? All right, and the last page is that spoiler alert. Because you can use a graphing calculator to convert a matrix in what they call reduced row echelon form. What reduced row echelon form is that you're going to have ones along the main diagonal and zeros above and below those ones. We call that the Gauss-Jordan elimination. Okay? The difference between Gaussian elimination and Gauss-Jordan elimination is this. Gaussian elimination requires you to have ones along the main diagonal and zeros underneath it, which is what we did in those two examples. With Gauss-Jordan elimination, you take it a little bit further. You have to have zeros above and below the ones that are along the main diagonal. Okay? And these are just the instructions on how to do this. But with that last example, let me go ahead and show you. First of all, the equation has to be in as an augmented matrix like I have here. And in this case here, we're going to do second and x to the negative 1, which is right here. Right above it is matrix, a matrix. Now, I'm going to put in a brand new matrix, so that means I'm going to use my right arrow key to edit, and then go to number 1. Now, let's take a look at the dimensions here. There are 3 rows, and there are 4 columns. 3 rows, 4 columns. So that first number is the number of rows, which is 3, and then enter, and then I'll type in the number of columns, which is 4. And then we enter each element row by row. So that first row, I'll type in 3, then negative 8, then negative 2, then negative 8. The second row would be 2, and then 2, then 6, then negative 5, 14. The last row will be 1, then negative 2, 0, and 2. And you must press enter after the very last element in the last row in the last column. And then I'm going to do second mode to quit to go to the home screen. Then I'm going to do second x to the negative 1. And underneath, from this menu, I will use my right arrow key to highlight math. Then I'm going to go down to find this menu item that says RREF. That means row reduced echelon form. REF is just row echelon form. This one is reduced row echelon form. That's the one you want to select. So press enter. Then I'm going to pull up that matrix that I had stored. So I'm going to do second x to the negative 1. And under the names menu, I will select the matrix that I put this one in. So in this case, I stored it in A, so I'll select number 1 for A. Also close the parentheses and then hit enter. Now you can see that the ones along the main diagonal, you got zeros above and below. If you look at the last column, that represents X, Y, and Z, which is this order triple that we came up with, 8, 3, and 4. Are there any questions about using the calculator to come up with our matrix?